So in case of convex lens, as you are able to see that the lens is there, and when parallel rays of light, where the parallel rays after they are passing through the lens, they are actually converging at a point. Are you able to see in case of convex lens?
Yes,
So
ma'am.
this point at that point at which all the rays after refraction they are converging, that point is called the focus of the
Focus.
convex lens. Yes. And actually, as when light rays or parallel rays of light while passing through the convex lens, they actually converge at a point. This lens is also having another name, that is called the converging lens also. Just in the it is the opposite in case of concave lens. You can see they are called the diverging lens. Why? You can see parallel rays of light are coming and falling on the lens, and after refraction, what is it? It is actually getting deviated away, and they will never ever meet at a point. Hana? Just to see second diagram. Is it clear? Is the diagram clear to all
Yes.
of you? In case of concave lens, so after passing through the lens,
Yes,
in case
ma'am.
of concave lens, these rays are diverging away, and actually they will never meet at a point. So we will suppose that these lens, if they are extended backward, they will supposed to be meet at a point, at a virtual point, but they are not actually meeting, so that there will be a virtual image will be formed at the point that is the focus. You can see the dotted lines are there, that has been extended back by the diverging rays, and that point in case of concave lens is the focus, and the image that will be formed in the focus will be a virtual image. So what is refraction? Anyone? What is refraction? How can you define refraction? Refraction is the bending of light, bending of the path of light when light passes from one medium to the other medium. Suppose over here you can see air is a medium and the lens that is made up of glass is also a medium. There are two mediums over here. Yes or no? Please do respond, children. Otherwise, I am not able to carry on. There are two medium over here. One is the air and the other one is the lens. Is it or not?
Yes,
Yes,
ma'am.
ma'am.
So what will happen? The rays of
Yes, ma'am.
light, the parallel rays are coming through the air and they are passing from this rarer medium. Air is a rarer medium, density of air is less compared to that of glass. So when air is coming from the when the rays of light is coming from the air and it is entering the denser medium in case of convex lens, first condition, what you will see, the rays will get converged to a point. It will bend towards the normal, towards, and they will meet at a point that is called the focus. Just it will be opposite in case of concave lens. Parallel rays that are coming while after passing through the concave lens, what will happen? They will diverge away and they will never meet. And if we suppose that if these diverging rays are extended backward, we will see they will meet at a point that is called the focus. Is it clear?
Yes, ma'am.
So now just a little bit we are going to read it about. Ranjali, are you able to see the presentation? Just let me scroll it down. You will read from lenses. Read it.
The bending of the path of light when it's moved from one medium to another is known as refraction. The object we see after refraction is called apparent object. There is exists some displacement between the apparent and actual object.
Yes. Next.
Con- Convex lens, converging lens. The convex lens is the lens which is thicker in the middle
Evening, ma'am.
at then the convex lens is the lens which thicker in the middle at the edges. A beam of the parallel rays of light falls in a convex lens from the left side. After passing through the convex lens, a beam of a parallel rays of light converge at a point as shown in the figure. A convex lens converges a beam of a parallel rays of light. Concave lens, diverging lens. A concave lens is a lens which is thinner in the middle than the edge. A parallel beam of a light falls on a concave lens as shown in the figure. After passing through a concave lens, the rays of a light of diverging or spreading out. A concave lens diverges a beam of a parallel rays of light Since a concave lens diverges light rays falling on it, therefore it is called diverging lens.
Okay, is this clear? Refraction and the way the light rays while passing through the lens, how they get diverged in case of both the lenses, convex and concave lens. Is this clear? So in case of convex lens, the parallel rays of light after passing through the lens will actually converge at a point. So actually converging means what kind of image will be formed in case of convex lens? Most case, genuine case,
Real
real,
image.
Real
because they
image.
are converging at a point, so we are going to have a real image. And what will be the nature of the real image? It will be always inverted, and we can have it on a screen. On the other hand, concave lens, what will be the image that will be
A
formed? That is
virtual
real, that will
image.
be virtual. Why it is virtual? Because actually after the parallel rays passing through the concave lens, they are diverging away from the normal and they will never meet at a point. If we just extend those divergent rays back, they will supposed to be meet at a point and we are not able to get any image on the screen, and the image that is formed, that will be straight, that is erect. So it will be virtual, erect, and we are not able to have it on a screen. Is this clear, children?
Yes, ma'am.
So these are the
Yes, ma'am.
characteristics of the image that are formed. That is written on the next paragraph. Yes, Ranjali, read image formation by lens.
Yes, ma'am. Images formation by lenses. Convex lens form a real inverted and diminished image when the object is placed very close.
Diminished. Diminished means small, very small. So the image that is formed always in any kind of lens, in case of focus, focus is will be the point image. That is like a point, dot, the diminished one. Yes, now continue.
When the object is placed very close to the lens, the image formed is erect, virtual, and magnified. They are also called as converging lens. This type of lens is also used as magnifying glass. Concave lens is always form a virtual, erect, and diminished image. They are also called diverging lens. They are used for camera lenses and binoculars.
Binoculars. Binoculars. You have seen binoculars with which the two eye binoculars you can see distant object very much
Yes, ma'am.
magnified. That is called the binoculars. And in case of concave lens, you will always have the virtual image, erect and virtual image. But in case of convex lens, just you see at one condition, the image will be virtual. Which is the condition? We have read about in my mirror also. In case of concave mirror, in case the property of concave mirror and convex lens are the same. The properties of image formed by a concave mirror and convex lens are same. They always, most of the time, they produces real image, inverted image, and they can be cast on a screen. But at one condition, they will form virtual image. What is the condition? What will be the position of the object where the image will be formed virtual in case of concave lens, sorry, concave mirror and convex lens? When it is very near to the lens or the mirror, that is in between the focus and the pole. When the position of the object will be in between the focus and the pole, then only in case of convex lens and concave mirror we are going to have virtual image. Am I clear? Magnifying glass, all of you, I think some or how you have seen the magnifying glass at home.
Yes,
Yes,
ma'am.
ma'am.
So if you
Ma'am.
just bring the magnifying glass very close to the letters of the sentence or of your book, you will see magnified image. If you place a screen in between, are you able to see have the image of that magnified alphabets? No. So that is one condition where virtual image is formed in case of convex lens. Am I clear?
Yes, ma'am.
Yes, ma'am.
Next, one more phenomenon that you have learned already in class 7. You know dispersion of light? Anyone? Do you know dispersion? What is dispersion of light? What is dispersion? Can you see the phenomenon over here? So, what is dispersion? Anyone? See the peak and
Ma'am,
tell. Yes,
ma'am,
Ravindra.
when white light, ma'am, splits into ma'am seven colors.
When
Splitting of
white
colors.
light passes through what? Passes through a
Ma'am, a
prism.
prism.
That is a prism. Yes, the three dimension of a triangle, है ना? So when it is passing through a prism, what will happen? This all this white light, beam of white light, you know, that is not a single color, not is made up of single color. They are having seven colors, and each and every color present in the white light is having its different refraction property. They will refract at different angle. Okay, and as a result, what will happen when they pass through this prism? This light will get scattered. This white light will get scattered into the seven colors, as you know, in Vibgyor, in the rainbow. So this phenomenon of scattering light when a beam of white light is passed through a prism is known as what it is called? Dispersion of light through a prism. Okay, how can you prove that light contains seven colors? How can you prove that white light contains seven colors? You have done that experiment in class 7 also.
Ma'am,
Anyone?
ma'am, by Newton's disk.
What you have done?
Ma'am, we used a compact disc and ma'am painted seven colors on it, ma'am, and when we spin it at a high speed, ma'am, it appears white.
Yes, it will appear to be white one. So this proves that white color, that a white light, that is a mixture of all these seven colors. Okay, and black color doesn't contain any color. Okay, white white light contains all the seven colors, and black, you know that we say black, it doesn't have any color. Okay, this much is clear to everyone.